Stay hungry, stay foolish.
What did James Bond and Lipitor have in common? What can we learn about human nature and world history from a glass of water? In Loonshots, today's guest reveals a surprising new way of thinking about the mysteries of group behaviour that challenges everything we thought we knew about nurturing radical breakthroughs. Drawing on the science of phase transitions, our guest tells us why teams, companies, or any group with a mission will suddenly change from embracing wild new ideas to rigidly rejecting them, just as flowing water will suddenly change into brittle ice. Mountains of print have been written about culture. Loonshots identifies the small shifts in structure that control this transition, the same way that temperature controls the change from water to ice. Using examples that range from the spread of fires in forests to the hunt for terrorists online and stories of thieves and geniuses and kings, our guest shows how this new kind of science helps us understand the behavior of companies and the fate of empires. Loonshots distills these insights into lessons for creatives, entrepreneurs, and visionaries everywhere. Over the past decade, researchers have been applying the tools and techniques of phase transitions to understand how birds flock, how fish swim, brains work, people vote, criminals behave, ideas spread, diseases erupt, and ecosystems collapse. If 20th century science was shaped by the search for fundamental laws, like quantum mechanics and gravity, the 21st will be shaped by this new kind of science. Loonshots is the first to apply these tools to help all of us unlock our potential to create and nurture the crazy ideas that change the world. We welcome scientist, entrepreneur, and author of Loonshots, How to Nurture the Crazy Ideas That Win Wars, Cure Diseases, and Transform Industries, Safi McCullen. Welcome to the show.
Thanks, Aidan. Delighted to be here.
I'm out of breath after that, man.
Oh, man. How do you think I feel after a couple hours of this?
Exactly. I love the book. I'm a huge fan of the way you've taught in this book, teaching principles over a bunch of information, and you did a phenomenal job with this book. And I have to say, I attribute it to your really diverse background.
Thanks for saying that. It's nice to emerge from 3 years in a writing cave and get some nice comments. It means a lot.
Absolutely. And I thought we would open with the story you opened the book with, which is the story of Rick Miller and the cancer drug.
Sure. Richard Miller was a Stanford professor and oncologist who started a biotech company developing new cancer drugs. And I got to know him because I was in the same field. Many years after he started his company, I also started a biotech company developing new cancer drugs. But what struck me enormously about Richard's story was that he had this idea for a new kind of cancer drug that violated everything people said you could do for developing new drugs. And I'll explain what I mean by that. Normally, when you develop a drug, the way that almost all drugs work, the drugs that you take every day, whether it's aspirin or Lipitor or some other drug, they're these kind of tiny little chemicals that you take into your body, and they go and they attach themselves to what's called a protein. That's some big, giant molecule. Think of it like a giant robot worker that does a bunch of stuff in your cell. The proteins are the worker molecules of the cell. And those little tiny chemicals go in to your body, into the bloodstream, into the cell. And when there's a malfunctioning robot, some protein that's doing a lot of damage in your body, for example, when you have a fever or you have a lot of pain, you have these overactive proteins that are causing that fever, that pain. And aspirin is one example, is a little chemical that goes in there. It's like a little wrench, and it goes in and it like plugs up that overactive robot and kind of calms things down. Cancer is very similar. It's an overactive protein, sort of like what's called a growth factor. You can think of it just as an accelerator pedal on the cell. And cancer is really when it happens when that accelerator pedal just gets stuck in the on position and those cells just start growing out of control. And most cancer drugs are like these little wrenches that go in the cell and try to block that robot, stop driving the cell to grow out of control. Normally, when you develop a drug, you look for wrenches that have a certain soft touch. They can go in and they can go out very easily. They don't attach too strongly because you worry that if they are really, really tight, like a really strong magnet, they could get stuck to the wrong thing and they could cause all sorts of problems. Richard Miller found this drug that he thought had a chance of working. And he treated patients every day at Stanford who had a terminal form of leukemia. But it was completely different than this usual form of drug. Instead of attaching gently and releasing gently, it was like a super strong magnet. It was like a piranha. It just attached and never let go. That's why I call it Miller's piranha. And when he went to try to convince people of his idea, they literally told him he was nuts. They said, you can't give a piranha to patients. It'll cause incredible damage. And I remember he was telling me how he was saying, look, these patients have got a few months to live. This is worth the risk. And he had all these reasons, but no one took him seriously. They said, you just don't do this. Fast forward, a couple of years later, there was a clinical trial. He finally scraped together the money to run clinical trials in human patients with leukemia for this drug. The trial was stopped early. It was in a couple hundred patients. Half got his drug, half got standard care. The trial was stopped early. Why? The physicians supervising the trial saw that there was such spectacular benefit in the patients who received his drug, more than 10 times the response rate from his drug compared to standard chemotherapy, that they decided it was unethical to continue the trial, that it was unfair to deny the patients in the control arm access to his drug. Not long thereafter, the FDA approved his drug, and his company, which had been struggling and had been delisted from the stock market, his company was sold for $21 billion. That's a classic example of what I think of as a loonshot. Something that everybody says will never work or is crazy, but turns out to be a very important idea.
And you do a great job throughout the book of these examples, and I thought we'd share more of them. But one of the lines I pulled out, one of my favorite from the book that emphasizes the need to nurture a loonshot is drugs that save lives, like technologies that transform industries, often begin with lone inventors like Miller championing crazy ideas, but it needs large groups of people to translate those ideas into products that work.
That's right. Here's why that's so important. There's a little bit of this myth out there that the big ideas that can transform our world are really driven by these, lone inventors and champions, and they get glorified on the cover of magazines. And the problem with that idea, which is a real big problem if we want to see important new drugs or important new advances in any field come to patients, come to all of us as consumers or customers. The problem with that idea is just that first step, the nucleation, is maybe 5% of it. Just having the idea is like having the ball on your goal line. And the idea itself, just the creation of that, is moving it maybe to your 5-yard line. Getting that idea into a product, manufacturing that product, delivering that product consistently to customers on time, on budget, on spec, is moving that ball the rest of the 95 yards down the field. So what people miss is they focus just on the 5% of the idea. That's the crazy artists with the idea, whether those artists are creative scientists or genuine artists and designers, programmers. That is just the first 5%. In order to turn that into, let's say, a drug that saves lives or a product that changes an industry, you need all the rest of it. You need to get that into a prototype. You need to figure out the right customers. You need to manufacture it. You need to deliver it to those customers in ways that it's clear that it will add value to them. That's the rest of it, and that requires a lot of people. So if you just focus on that first 5% of the idea, your idea will go nowhere. You need to do both things. You need to understand how to cultivate the artists and the ideas, and understand at the same time how to cultivate the soldiers and getting the ball the rest of the way down the field. And that's the trick. How do you do both at the same time?
And you mentioned cultivation there. And one of the things that's common in the world of innovation is that we need to cultivate culture. And you say when you hear culture, you think of yogurt. And you tell us that structure is much more valuable than culture. And here you cite the story of Nokia, for example.
Right. So let me explain what I mean by that, the difference between culture and structure. You can think of culture as the patterns of behavior, the things that you see on the surface. Let's say in one case, you have a very innovative culture. In the other case, you have a very political culture. And I think we all know what we mean by a political culture. Everybody's stabbing each other in the back, trying to climb up the ladder of the hierarchy. So you could spend a lot of time on culture and trying to change one into the other, but that's very difficult. The analogy I use there is with a glass of water. Culture is whether the molecules are sloshing around like a liquid or they're held rigidly in place like a solid. It's the same exact molecule, two very different patterns of behavior. That's what you see. Underneath that is something that drives those patterns of behavior. So in a glass of water, what is that? Temperature. High temperatures, the molecules will slosh around. Low temperatures, the molecules will be rigid in place. They'll freeze like ice. So it turns out there's a very similar way to think about the behavior of people and teams and companies. And that's not just a metaphor. You can actually work through what are individual incentives inside teams and companies. And you can show that as teams and companies grow, those incentives will suddenly shift. When teams and companies are small, everyone's aligned around making that crazy idea succeed. Why? Everybody's stake in that crazy idea is huge. If you're 10 people developing a cancer drug and it works, everyone's going to be a hero and a millionaire. If it fails, everyone's going to be unemployed and looking for a new job. If you're a 100,000 person company, you have lots of people working on lots of drugs. Your one drug doesn't really move the needle for that company very much. On the other hand, if you can get promoted, your salary might go up by 20 or 30%. And then you keep doing that, you keep getting promoted, you could get real growth. So we can talk about what we see, patterns of behavior, innovative culture, or political culture. But underneath that is the incentives, the design of our system. If you reward rank up the hierarchy, that's how people are motivated and incentivized and compensated, is what level they are in the organization. You're going to get a political culture. No matter how much screaming or yelling or encouragement or movies or singing Kumbaya, you're going to get a political culture if you reward rank. They're going to stab their neighbors in the back and shoot down their ideas so they can go up faster. On the other hand, if you reward mostly results and ideas and the pursuit of new ideas, you're going to get an innovative culture. So that's what I mean by culture versus structure. Structure is what's underneath. Structure can drive culture. Just like in a glass of water, no amount of yelling at ice is going to melt it. But a small change in temperature can get the job done. A small change in temperature can melt steel. So that's what makes this so interesting, is that it's a new way to think about designing more innovative teams and companies, a new set of tools, a new set of techniques that's different than all the thousands of books on culture.
We might come back to phase transitions as well, because it's the key lesson that I took from the book, this idea, and I love the concept. But I mentioned Nokia because Nokia was lauded as one of the great innovative companies and underpinned by its culture, but it ultimately failed.
Right. Nokia was an example of one of the things that got me a little suspicious about this culture story and starting to try to look beneath the surface. Was there something else? So Nokia was a company, for those who may not remember, that was famous early on, mostly for rubber boots and toilet paper. It was a conglomerate, did oil, rubber, manufacturing, pretty boring standard conglomerate. And then a management team took over, and over the course of 15, 20 years, turned it into the leading smartphone company in the world. At its peak, it was making 50%. One out of every two smartphones in the world was being sold by Nokia. Its market share was much bigger than Apple's market share today. It became, for a period, the most valuable company in Europe. Not long after it reached that peak, there was a small team of engineers inside Nokia that developed a new crazy idea. They had launched the first car phone over those 15 years. They had launched the first wildly popular GSM phone. They had just done so many innovations. And so not long after it had grown and reached its peak, a small group of engineers inside the company said, hey, we have a new crazy idea. This was 2004. Why don't we build a smartphone with a really big screen? Let's make it a touch screen. Let's put on this awesome, beautiful camera. And we have a second crazy idea. We're going to sell something called applications, apps, and a store online. And people can buy that and they can sort of program with their phone and download these things. The same group that had led Nokia for the past 15 or previous 15 or 20 years to this incredible heights of success rejected those Loonshots. They rejected both of those ideas, shot them down. So that little group of engineers 3 years later in 2007 watched from far away on a stage in San Francisco. They, whether they were watching on TV, I don't know, but they saw Steve Jobs unveiling the iPhone with exactly the same ideas. And just a few years later, Nokia was irrelevant. They went from just over $300 billion in market value to selling their entire mobile phone business to Microsoft for around 12 or 13 billion. So that was a loss of $250 billion. And that's an example of a phase transition, a group that has grown from a small, kind of wildly innovative phase to something that is ossified, that has become solid, and that rejects new ideas.
Yeah, and I love the line you have in the book on this. The same person that can act as a project-killing conservative in one phase or one context is a flag-waving entrepreneur in another. And it's the key, it's that structure thing coming to the fore again. But I'll come back to Apple, because you tell a brilliant story about Apple and Steve Jobs and how he understood the different phases after making mistakes in the initial sense. You tell us about the failed attempts to innovate in the US Army by Highland and Youngs and their decade-long tunnel of neglect and skepticism within the Army.
Yeah, I think this is another example that one of the things that made me first begin to look for solutions in what might seem like a very strange place, which is the Army and the Navy. And that came about because of a personal story. I got called, maybe it was 7 or 8 years ago, to work with President Obama's Council of Science Advisors on a project on the future of national research in the United States. And the first day, I was at the time still running my biotech company, and I flew down to DC for the first meeting. And at that meeting, the chairperson of the group stood up and said, your job is to write the next generation of the Vannevar Bush report. Unfortunately, I had never heard of Vannevar Bush or his report, so I immediately thought, oops, I'm the wrong person for this job to write a recommendation to the President of the United States on the future of national research. Because I didn't know that much about the history of science or science policy and how it affected the nation. But I did read a lot and read very quickly. And then certainly in the last 5 or 6 years, spent a lot more time digging into that story, because what was so interesting about that story is that the Allies began World War II in a very dark situation. Had there been had there been a prediction market, the odds would have almost certainly favored Nazi Germany. And here's why. The Germans had developed this new submarine technology called the U-boats, which looked ready to strangle the Atlantic. And that's, in fact, exactly what happened in the first 4 years of the war. The U-boats were sinking more ships every month than the Allies could build. Second, Nazi Germany had developed these remarkable planes, the planes of the German Luftwaffe Air Force, that outclassed anything that the Allies had, and it looked like they might bomb Europe into submission. And that's exactly what happened in Western Europe in a matter of just a few weeks in 1940. And finally, two German scientists, right before the main outbreak of the war in early 1939, discovered something called nuclear fission, splitting the atom, which put Hitler within reach of the most dangerous weapon ever invented by man, the atomic bomb. So, had you been a betting person, you would have been absolutely right to place your bets on Nazi Germany. Around that time, a man named Vannevar Bush, who was Dean of Engineering at MIT, quit his job, moved to Washington, and talked his way into a meeting with President Franklin Roosevelt. It was a 10-minute meeting, but it probably changed the outcome of the war, more than any other such meeting. What he told FDR was, there's a war coming, and we're going to lose that war. It's going to be a technology-driven war. And we are far behind Nazi Germany, and the Army and the Navy, the military, will never catch up in time. And Bush knew what he was talking about. He'd been working with the Navy since World War I, since he was a young man, advising them on technology. And he'd been hearing about Nazi Germany from all the fleeing Jewish refugee scientists. So he handed FDR one sheet of paper, which was his proposal, and he, in 3 short paragraphs in the middle, it described what he asked for, which is, he told FDR, I would like you to authorize a new group in the federal government that would report directly to me, and I will report only to you, and I will mobilize the nation's scientists for war. And the system that he created was a system for innovating astonishingly fast inside large organizations. And I realized in all the time that I'd spent inside both small companies and large companies, every one of which is desperate for nurturing those crazy ideas, nurturing those loonshots that will change the industry and give them an advantage, give them an edge. Bush had figured out a system, and his system came up with the technologies that turned the course of the war, that turned it all around, that rapidly caught up with and soon exceeded the technologies that Nazi Germany had. And he was absolutely right. It ended up being a war that turned on certain critical technologies. So I took a bunch of lessons from what Vannevar Bush did and translated it back into some principles that we can use today.
I thought the really interesting one was radar. Hyland and Youngs had discovered this, had explained it to the army, because oftentimes when we hear about innovation, it's to do with a company or a case study or a rejected innovator, and that's the story we hear. But I love the way you took your framework and you applied it to history, because this is something we don't usually see. And I love the story of Hyland and Youngs and how they got rejected by the army, despite handing them years before Pearl Harbor the antidote to being bombed.
Yeah, that's right. And it's one of the things when you dive into the history and really go into the books. I ended up speaking with the Office of the Naval Historian and getting access to some important materials, which were very helpful. The popular history of radar very often credits discovery in Britain in 1935 of the principle of radar. But in fact, as you just mentioned, the principles of using radar in battle, which were crucial in turning the course of the war, were discovered 13 years earlier by these two scientists working inside the Navy, the U.S. Navy, the Naval Research Lab. And they discovered it somewhat accidentally. They were testing communication equipment between ships. They were using radio signaling. They were experimenting across the Potomac River in Washington, D.C., and they noticed some weird blips between the receiver and the transmitter and the signal they were receiving whenever a ship crossed their path that was sailing down the Potomac River. They had the receiver on one side, the transmitter on the other. And pretty quickly, they figured out that those blips were due to radio wave interference, and that radio wave interference could give you an entirely new way of detection, not just communication, but of detecting ships at night, ships in the fog, ships over large distances, and that could be an incredibly important military advantage. But their ideas were rejected inside the military, similar for the reasons that Richard Miller's ideas were rejected. Everyone said they were crazy, and they looked at the flaws of those ideas rather than the possible merit on how to fix those flaws. And that's one of the lessons, is that loonshots always arrive covered in warts. They always have lots of reasons one could think that they would never work. And when you're inside a large group or a large organization, it's easy to shoot down those loonshots. People want to advance. They want to go up the career ladder. So they just point out all the flaws in these early stage new ideas. And if they do that consistently enough and champion some more favored, groupthink mainstream project, they might go up the ladder. So Hyland and Young's ideas were rejected. They were rejected, and they just sat there for 8 years until they discovered another interesting idea, again by accident in 1930, and that is that if you point those radio beams up in the sky, you can actually detect, through the same sort of radio wave interference stuff, planes at a distance. And they got very excited again, and they said, holy cow, this could really give us an advantage in detecting enemy aircraft and eliminating surprise, which is absolutely crucial in any battle or in any war. Again, they were rejected. Another 5 or so years until finally there was one guy who's almost forgotten, is almost never mentioned in any of the popular histories of radar, a guy named Deke Parsons, who was a Navy guy who happened to have a passion and curiosity about basic science and physics, and sort of stumbled across this group, this little team of scientists. And when they showed him what they had done a few years earlier, he was like, holy cow, are you kidding me? And he, because he spoke the language of the generals and the commanders, and he could translate. On the one hand, he was able to speak to the scientists because he knew enough science, he knew their language. On the other hand, he was able to speak to the generals because he knew how they liked to hear things and how they understood things. So in some sense, he was bilingual. So that guy helped launch the U.S. effort. And many years later, he said he was rose up in the right. He was a very distinguished naval officer. He rose up in the ranks and was rewarded and recognized at the time. Many years later, not long after Pearl Harbor, when radar had just been discovered, but it had just been implemented, it had just been rolled out into the field, but it was too early. People didn't really know how to use it. And so in Hawaii, in Pearl Harbor, on December 7, 1941, the U.S. fleet was caught completely by surprise by a large group of Japanese planes. And not long after that, Deke Parsons, who later became an admiral, said, if only we had been able to advance radar just a couple years earlier, 1 or 2 years earlier, how many lives might have been spared in the Pacific? So that's an example of the importance of understanding this system of innovation, what you need to do to nurture those crazy ideas deep inside large organizations. How do you help them get out? It doesn't apply just to drugs, or it doesn't apply just to tech companies. It applies to nations as well, nations who care about national security. And that's where I got quite a few of the ideas and principles, is translating back what did Vannevar Bush do then, and how does that fit into these kind of broader ideas and models that I talk about in the book, the sort of phase transition that you talked about, having artists and soldiers in 2 different phases. And what does that mean for us today? How can we turn that into sort of actionable things that we can use in our companies today?
You talk about the Bush-Vail rules that come from all this, from all the lessons, from all the history that you read and overlaying your framework. And you mentioned there that the real synthesizers of innovation, like Bush, like Jobs, like Isaac Newton, all understood how to influence the system, how to influence both sides, both elements of the phase, the frozen, rigid system and the liquid, emerging, wart-covered, ugly baby. And they know how to speak both languages. They're bilingual. And I love this because this is what you tell us Bush was excellent at. But I'd love if we'd share a little bit about the Bush-Vail rules. Then we might talk about the 3 deaths thereafter.
Okay, sure. So first, there are 3 key elements to what Bush did, and I'll explain later who Vail is, Theodore Vail, which is kind of where Bush got his ideas. And Vail was in the business world, although this is something that I first understood in the military in the course of World War II. In some ways, Bush took his idea from the business world. So first, I'll tell you how these ideas and these principles ended up influencing the outcome of World War II. And then the 3 basic ideas that we can take away from it, which I think of, since I don't have a very good memory, I tend to think of them visually as an ice cube, a garden hoe, and a heart. And those were the 3 main rules. So I'll tell you what happened and then how the ice cube and the heart and the garden hoe played out into getting that outcome. So what happened, Bush had his meeting with FDR in 1940, in the summer of 1940, and FDR agreed, and he created these 2 groups, this one group of crazy scientists, let's call it the artists, and left the military along the soldiers to do these 2 very different tasks. The soldiers to focus on the very hard job of making millions of guns and thousands of planes and thousands of ships and directing millions of soldiers in battle. And the system that the military had set up was excellent for that task. The culture that the military had, the rigid, tight discipline, tight execution, is exactly the right culture for that task, which is why Bush didn't try to change that culture. He separated the phases, and that's the ice cube. You separate your solid and your liquid. You keep the solid over here, and the liquid you put somewhere else. You separate the artists and the soldiers because they speak very different languages. So that's the first thing Bush did, is he separated his artists and soldiers. The second thing that Bush did, I think of as the garden hoe, and that is he led more like a gardener and less like a Moses. And here's what I mean by that. There's this popular image of the great leader as Moses, who stands on the top of a mountain and raises his or her staff and anoints the chosen project, whether that's the iPod or some other important new technology, and then parts the seas so that project can swim, walk through the organization. But in fact, that's a false myth. Leaders who lead like a Moses, that might succeed the first time or the second time with whatever the chosen project is that they anoint, but eventually they'll make a mistake and the competitors will eat their lunch. The best leaders are more like Vannevar Bush, where they manage the touch and the balance between these 2 groups, between the artists and the soldiers. In other words, they manage the transfer between the 2 rather than the technology. They don't get too much into the weeds of here's one technology, this is the one we're going to do, everybody else move aside. They focus on the communication, the transfer between these 2 groups, because that's where most innovation breaks down. When do you get a baby idea out of this nursery of crazy ideas and move it into the soldier group? How do you get uptake in the soldier group? Because soldiers will resist new ideas. They always arrive covered in flaws. They're busy. They want to use the tools at hand, the things they're familiar with. They don't want to spend a lot of time. And they speak different languages than the crazy scientists, the crazy artists. They have totally different language and values and places that they come from. So the second thing Bush did is he managed more like a careful gardener, nurturing both groups and managing the transfer between them. So here's what happened. After his meeting in 1940, just as he had expected, the U-boats grew into the most dangerous threat of the war. Although Britain had beaten back Germany, it helped enormously by radar in repelling the German Air Force. Hitler and his generals, and especially the admiral of his navy, realized if they couldn't bomb England into submission, and England was the last remaining Western European country, they couldn't bomb it into submission, they would starve it. England, of course, is an island, and it depended on oil and other imports for food and so on. So if the Germans could cut off the United Kingdom from outside support, they could eventually starve it. And that's exactly what happened in the first 4 years of the war, as losses to German U-boats grew every year of the war from 1 million to 2 million to 4 million to 8 million. Although there's a lot of popular story about code breaking making a difference there, but in the end, it really didn't make a difference at all to the outcome of that battle, the Battle of the Atlantic, and trying to starve England. In large part because what's left out of most of the histories is that the German intelligence called B Dienst had 1,000 people working on breaking British codes, and they'd actually done a far better job in breaking British codes than the other way around, and they were reading almost every intercepted transcript. So they knew where the ships were, even if, for a few months here and there, the British were reading the German codes. So U-boat losses growing. And eventually, by the spring of 1943, more or less 4 years into the war, England came enormously close to running out of oil. England came within 3 months of running out of oil. What do trucks run on? Oil. What do tanks run on? Oil. What do planes need? Oil. No oil, no war. It would have been all over. And Churchill and Roosevelt and the main generals on the Allied side all knew that. And the Germans knew that. That was their strategy. They had realized that they could win the war with these U-boats, with cutting off England, and then there would be no defense left for the Allies in Western Europe. What happened? In March of 1943, the first Liberator bombers of long-range planes sailed out over the Atlantic with a new technology from Vannevar Bush's group. There was a handful of new technologies, but the most important one was something called microwave radar. It was a technology that allowed the planes for the first time to see the U-boats. They lit up on their screen. And within 30 days, the pilots sunk 1/3 of the German U-boat fleet in the Atlantic. They were shooting them down like shooting fish in a barrel. 6 weeks later, the head of the German Navy, the Admiral Karl Dönitz, sent out a radio signal across the Atlantic. Withdraw. All U-boats were to withdraw back to Germany. The Battle of the Atlantic had been lost. And the lanes were cleared to resupply England, and the lanes were cleared for an Allied invasion of Europe. And after that point, the outcome of the war was almost inevitable, as both Churchill and Roosevelt knew, and as many of the German generals knew. So what are the lessons? Number one is the ice cube. You separate your artists and your soldiers because they speak entirely different languages. Number two, you manage the transfer, not the technology, meaning you lead like a gardener, not a Moses. That's the gardener. That's the garden hoe. And number three, and this may be most important, especially in our culture today, it's just in the general sort of press coverage that you read in magazines and books. Number three was the heart. And by the heart, I mean love your artists and soldiers equally. Many people had tried to influence the military. Many scientists who were aware of the technology gap had tried to influence the military. Many of them before Bush, all of them had failed. One of the reasons Bush succeeded is that he respected and trusted the military men. He didn't try to change them. He understood what they were doing. He valued what they were doing. He understood that you need both your artists and your soldiers, and you need to love them equally. That trust and respect and love is what allowed him to succeed when so many others had failed. So that's the ice cube, separate your artists and soldiers, the garden hoe, be a gardener, not a Moses, and the heart, love your artists and soldiers equally. Those three together, which Vannevar Bush brought to life in those crazy couple of years of the Second World War and that time of national crisis and world crisis, those three things are what helped turn the course of the war.
When you talk about different values there, Safi, you talked about the heart. And I thought, firstly, there's different values between soldiers and artists. And you mentioned, for example, stake versus rank. But what I found really common to all the innovators and all the change makers or synthesizers, as you call them, and the drivers of Loonshots is the why was always bigger than the try. So they were always willing to give it more, go through the three fails that we'll talk about in a little while. They were always aiming for something bigger than wealth or a successful exit for their business. I found this was common to you as well when I read about you, and that your mission in biotech was driven by your desire to cure your own father. May he rest in peace.
Yeah, I think one of the reasons I got motivated to write this book and try to get this idea out broader is when a few years after I started my company, my father got sick. He developed a type of leukemia, and for which there were no drugs that did anything. And it was doubly hard to be in the industry and see people working on promising ideas and know that there was nothing that was ready or available, nothing that I can do, even though I was in the industry and working on new cancer drugs. And it was frustrating to see that there were so many promising ideas buried inside the basement of large groups or large research groups and large organizations, not because any of them are bad people. Every one of those people wants to develop a new drug. Every one of those people wants to go home to their spouse or loved ones and say, I've done something that will help save lives. It's the collective effect of bringing people together. It's the solid versus the liquid. It's not what any one molecule decides. So it was very frustrating and depressing to see that. And it was that reason that really drove me to try to get these ideas out there to help groups that are sitting on important new ideas liberate those ideas and get them out there to patients, or if you're in the tech field, into customers, if your focus is on empowering people or spreading happiness or elevating the poor, whatever your mission is. I wanted to do something broader than just the one company. I wanted to help groups more broadly liberate those promising new ideas. So, as you say, that's right. That was a big part of the motivation for me.
That drive is absolutely essential. And I mentioned that because of the fails that you will go through. And this is common to every innovator you talk about in the book, went through an unbelievably hard time. That's often the revisionist story ignores that because it makes it too complicated. There may be a couple of challenges, but there's loads of challenges. And you mentioned your friend, Jew the Folkman, may he rest in peace, and that he had this phrase, you know how far you're getting by counting the arrows in your ass.
That's right. You mentioned the three fails. So that I got that term or that idea really stuck in my head one evening when I was in Boston, and a guy named Sir James Black, who is a brilliant Scottish scientist, won the Nobel Prize for developing two of the most important drug categories of the 20th century, beta blockers and histamine antagonists. Sir James would fly over periodically and come meet with our team in Boston and advise us on our research. And one evening, when I was pretty tired, we'd been going for probably 12 hours, 14 hours, and it was getting kind of late. And I couldn't believe that Sir James, who was probably in his 80s at the time, was still going strong. And I was ready to just get up and crawl home to bed. And he just said, "Oh, stay a little more, have another whiskey with me." He definitely liked his whiskey. So we got some drinks and we started talking. And I told him I was pretty depressed about a certain project in the lab that hadn't gone well. And it looked like it had some failures in the lab. And I was kind of depressed about that because it seemed so promising. And he kind of leaned over and patted my knee and said, "Oh, my boy, it's not a good drug unless it's been killed 3 times. And I thought about that over the years. And there's something really to it, because if a project doesn't meet any resistance, if it doesn't stumble, then probably other people would have been there pretty fast. It's those stumbles that typically prevent most people from going the distance and finding the gold at the end after those 3 failures, after those 3 big stumbles. And so the more I looked at the real history of big breakthroughs as opposed to the revisionist history, the more I saw that everywhere. For example, one of the most important medical breakthroughs of the 20th century, in addition to the drugs that Sir James developed, was the drugs that lower cholesterol, called the statin drugs, Lipitor, Crestor, Zocor, and others. Those have probably saved millions of lives, certainly prevented millions of heart attacks, and have saved millions of lives over the last 20, 30 years. And that idea, when you peel back the real history, absolutely fit his description. So I'll give you an example. I'll tell you what I mean. When we first understood in the 1960s that elevated cholesterol was associated with high rate of heart attacks, a bunch of groups, physician groups, research groups, sometimes some companies kind of rushed in and said, well, let's see what we can do about lowering cholesterol. A lot of that was dietary, eat less eggs and so on. But all of those trials, clinical trials, failed, even though the popular press seemed to continue to think eating less cholesterol was a good idea. And so there were all these you can still find in supermarkets, low cholesterol this and low cholesterol that. But all of the trials repeatedly showed that eating less cholesterol didn't influence blood cholesterol levels, which seems kind of counterintuitive, although today we understand that most of the cholesterol you have inside is synthesized inside from sugar and other stuff. So it doesn't matter that much the cholesterol that you eat. Your body makes cholesterol. Anyways, when we first understood that cholesterol is associated with high rates of heart attacks, a scientist in Japan named Akira Endo said, well, this is pretty important. And he decided he wanted to make a new kind of drug that lowers cholesterol. And he started it took him quite a few years. And he finally identified a promising drug that seemed to lower cholesterol. But right around that time is when all these results came back that lowering cholesterol did nothing. And some of the early trials with some other kinds of drugs not only said that it didn't work, but that lowering cholesterol could be dangerous. They saw some deaths and some nasty side effects with their drugs. So very quickly, the community, the scientific, the research community, concluded that lowering cholesterol was an incredibly bad idea. And they even had a good reason why. They said, well, every cell in your body has cholesterol. So if you take a drug that lowers cholesterol, that's going to be a disaster. You're like taking a drug that will poison your whole body. So nobody should do this. It's a terrible idea. And that was the first death, because many people gave up on the project. But not this guy, Akira Endo, in Japan, this young scientist. He kept going, convinced the people he was working with that they should give it a shot. And then he did, when he finally had his drug, he did what you usually do in early drug discovery in the lab. You test it on some animal models, typically mice and rats. So he gave it, very excited, gave it to those mice and rats, and nothing happened. And that is almost always the end of any project. If the drug doesn't work in the lab, there's no reason. Why would you think it would work in people? So done. That was the second death. As it turns out, years later, we realized that it was what you might call a false fail. It was a flaw in the experiment, not in the idea. Because it turns out mice and rats have only what we now call good cholesterol, HDL. And the statins, Lipitor, Crestor, and so on, work by lowering the bad cholesterol, the LDL. Well, the mice and rats don't have that. So, of course, when you give them the statins, nothing happens. It just turns out mice and rats are an unusual species in that. Other species like chicken, dogs, primates, humans, have both types. So eventually he kept going despite everyone else leaving the field, and bumped into a colleague who was working with some chickens and convinced him to try his drug. And incredible results. Worked. It was fantastic. It was enormously excited. They decided to start a study in human subjects with enormously high levels of cholesterol who were at risk for dying young because of that, through heart attacks, a certain type of disease called FH, familial hypocholesterolemia. They started the trial, and just after they started the trial and they were starting to see some good results, another group came back saying, stop everything. We've given this drug to dogs in the standard safety studies required by the health agencies, and we see some bad signs. We think this drug might cause cancer in dogs. Boom. End of program, terminated, stopped, completely unplugged, finished. That was the third death. As it turns out, they were wrong. Many studies later, a few years later, showed that they had seen a flawed signal. They didn't interpret it correctly. And another company, not this Japanese company and this Japanese scientist, went ahead. They kind of borrowed Akira Endo's results and went ahead. And because of Akira Endo, who persisted, and this other company that eventually ran some better trials and went ahead, because of that, millions of lives have been saved. So that's one example of the 3 deaths at work. One example, what Sayer James told me that one night over a couple whiskeys: it's not a good drug unless it's been killed 3 times. And that lesson applies much more broadly. And the reason it's so important to understand that is that there's this saying that's out there. It's very popular in Silicon Valley in the United States. And it's sort of spread in a lot of places with these sort of management buzzwords, things like agile and lean this and lean that. And that's the idea of fail fast and pivot. Fail fast and pivot. The idea being there, as soon as you see something fail, move to something else, pivot. Well, the problem with that idea is if everybody does that, then everybody just gives up at the first death. As soon as they hit a stumble, a bump in the road, they just make a turn and go somewhere else. They never get to the gold that's there after the first few stumbles. They might get to some quick hit, easy idea, but they'll never get to the big breakthrough that can transform an industry or can save millions of lives. So that's the 3 deaths and why you should ignore that rule. If you really want to change the world, you should ignore the rule of fail fast and pivot.
And this, again, brings to light the importance of that dedication to your project or to your mission, to your why, that you and all the other innovators have had. But you highlight here a really important principle, and one that you bring through the book, which is LSC, listen to the suck with curiosity.
That idea I got from a guy named Judah Folkman, whose name you mentioned earlier, who was a brilliant physician and scientist who spent much of his career at Boston Children's Hospital. He was chief of surgery there for a long period. And when he was a young man in his early 30s, Judah had an idea of a new way to treat cancer. And that idea was to block the growth of new blood vessels that can feed a tumor. Today, that sounds like a pretty reasonable idea. If you're trying to build something, if you're trying to build a house, you need to lay down pipes to bring in the gas and the water and bring in supplies and so forth. And a tumor, when it's growing in the body, needs to bring in oxygen and nutrients and have pipes that can take out the waste and so on. But at the time, it was considered a really dumb idea. At the time, there were only 2 ways to treat cancer: chemotherapy and radiation. So you bomb the cancer, you just basically poison it, or you burn it with radiation. And those were still, in those days, pretty new approaches, and there was some good progress with those. So everyone dismissed his idea and alternative approaches like what he was suggesting. And he said, look, I'm a surgeon. I operate on lung cancer patients, and I see that these tumors have these blood vessels there. And I've done these experiments when in the lab, when you take away those blood vessels, these tumors don't grow anymore. People didn't believe him. They said, well, that's just inflammation or irritation. For 30 years, every year, he was ridiculed or shot down. His grants were rejected. And one of the things that I learned from him, and I've seen with other really great innovators or creatives who come up with an idea and persist through the failure, is that they have a different mindset to negative feedback. And I'll give you an example of what I mean by that mindset, which I call LSC. Since I don't have a very good memory, I can only remember things in acronyms. So LSC is listen to the suck with curiosity. So here's what I mean by that. When you get an idea, when you have an idea and you're really passionate about it and you put your heart and your soul into it, when an investor rejects that idea or a customer says, no, I'm not interested, or you have a partner and the partner walks away, your temptation is to dismiss that feedback. Or if an investor tells you your idea sucks, your temptation is to want to punch him in the face. That's not a very good reaction. That's not a very useful reaction. It's not really going to help you. What you really want is to listen to that idea. Now, there's all this sort of management talk about active listening, and I got all that advice, all these sort of training workshops for years. But active listening is this sort of principle, well, repeat what you heard so people know that they've been listened to. That's also not good enough. If you just say, okay, I hear you, you're not interested in my product, that's not very useful. The really great inventors take off their defensive hat, the dismissing hat, the attacking their challenger's hat. They set aside their feelings of rejection and desire to call their friends and their mother and just get reassured that they're on the right track, which is a very understandable emotion, but you just have to recognize it, acknowledge it, and then set that emotion aside, because what you really want to do is listen to that suck with curiosity. You want to put on your detective hat, your Sherlock Holmes hat, and say, help me understand. If it's in a customer that's not interested in your product, can you walk me through what exactly is not working here for you? Or an investor, could you help me understand? And usually they don't want to do that. There's very little in it for them to walk you through, to take the time to give you that feedback. But only by pulling on that thread and pulling on it with curiosity, polite questioning, getting them to give you those little nuggets. Only by doing that do you have any chance of finding that little gold nugget of some surprising insight that you weren't aware of, some flaw in what you're doing, or how customers are perceiving it, or how investors are perceiving it, or what might be out there in the market that you're not aware of, that your competitors are doing, but your investors and customers know. Only if you listen to that suck with curiosity can you pull and pull on that thread, and eventually you might find that little gold nugget. And that gold nugget is the insight, the surprising insight that can help you turn it around. So all those sort of innovators who just sort of dismiss and attack and reject anybody who challenges them are going to miss that gold nugget. Only the great ones who pull and listen to the suck with curiosity might find it. And so here's an example with Judah, where I sort of first saw that in action and then consistently saw it with him over the years. One year, I remember he got out of his house one morning, picked up the newspaper and read in a headline, famed cancer researchers' results are not reproducible in the lab. Somebody else had tried to reproduce some of his results and had failed to reproduce them. And the news had made a national newspaper headline. That kind of negative result and negative publicity can end a career and would obviously make anybody incredibly angry. And so most people might react with fury at the newspaper or whoever told that story to the newspaper and spread it. Instead, Judah called up that other lab and said, help me understand. Could you walk me through how you designed your experiment and what you did step by step? And by going with them patiently step by step, he discovered that when he was shipping his product, his drug, across the country, and the way that he froze it down and the way it was thawed out, was changing the product, changing the drug, damaging it. That not only solved the problem, and then he sent them the new drug, we came up with a new shipping method and the results worked, but it gave him interesting insights for the future that he could use. That was an example of listening to the suck with curiosity rather than answering your attackers with anger. And that LSC for me has been enormously important. And I gave you a science example, but it's true if you're a writer and somebody doesn't like something you've written, you just get angry and reject it and say, oh, they're idiots. Or if you're developing any kind of product, whether it's a tech product or a consumer product or some kind of gadget and people don't like it, you just dismiss them. Or you could invest the time to listen with curiosity. What is it that's not working right here? What is it that's not resonating? The people who do the latter are the ones that tend to succeed.
So you mentioned, Safi, the Moses trap there. You mentioned that earlier on. And I'd love to zone in on this a little bit. This is the idea of the innovator who only chooses what will work and what doesn't. And that is the image. And there is actually an image. There's a cartoon, I think it was on Time magazine, of Steve Jobs holding two tablets. And I know it was about tablets, but when you mentioned this in the book, I thought, yeah, he's talking about Jobs. But Jobs was guilty of a different thing that you talk about in the book. And this was this idea of phase transition and separating the two teams. But Jobs called the soldiers bozos.
That's another example of the revisionist history versus the real history. And if you believe the revisionist history, you miss a lot of the genuinely important and valuable lessons. And so there is this myth of Jobs as this great Moses who stood on top of the mountain and, anointed the chosen projects. And that's why we got the iPod and the iPhone and the tablets or the iPad and so forth. But that's not what really happened. In fact, when Jobs led like a Moses, which was the young version of the Jobs 1.0, it was a disaster. So here's what I mean by that. When Jobs first started Apple with Steve Wozniak, the Apple II, their first real personal computer, was a big hit. And of course, there were a lot of competitors and they started rising up. So they had to figure out what to do next. And so Jobs worked for a while on the Apple III, the next product. It didn't go very well under him. And then Lisa, which was the next sort of follow-on product, and that didn't go very well. So he sort of searched around, and there was a young guy working on another project internally called the Macintosh project. So the people in charge of the company at the time gave that to Jobs. They figured that he wouldn't do much harm there. So then he went and worked on this Macintosh project, and he told his troops, well, you guys are the artists. Jobs, of course, saw himself as the ultimate artist, and he said, we are the pirates, we are the artists, we're doing the crazy, wild new ideas, and everyone else who's working on the franchise, those legacy projects, the Apple III or whatever, those are bozos. They're the regular Navy, they're just bozos. And the hostility he created between the two groups was so intense that those who were working on the franchise, which was close to 95% of the revenue of the company, took to wearing a button with a red sash and Bozo the Clown to basically say, look, we're not bozos. And of course, they were working on very important innovations, but they were, for the Apple III, including Steve Wozniak, his original partner, was working on that. The hostility was so great that the road between their two buildings was known as the DMZ, the Demilitarized Zone. Eventually, people started leaving on both sides, the franchise side, the Apple III side, and even in his own group, because it was such a kind of hostile environment. And when the Macintosh launched, it was a flop. There was a great ad and great publicity, but the product itself was too slow, it was underpowered, it overheated, and it didn't sell. Other computers, other makers rapidly passed Apple by. And the franchise projects didn't do very well either, because so many of the good people had left. So eventually, Jobs was forced to step down, and he left the company, which was justifiable at the time, because he had made that mistake. He created hostility between the artists and the soldiers, and that was a big mistake. Fast forward 12 years, when he came back to Apple, who did he appoint as his artist, as one of his two hands? Johnny Ive, kind of the ultimate product design person. If you have an Apple product in your pocket or on your desktop or on your wrist, it was probably designed by Johnny Ive and his group. And who did he appoint in charge of operations? A guy named Tim Cook. Cook, in his previous job at Compaq, was known as Attila the Hun of inventory. And if there is a better name for a soldier inside a company, I don't know it. That's right. And unlike the popular myth, Jobs led by balancing the artists and the soldiers. He, of course, challenged both of them very intensely. But being a gardener doesn't mean that you don't challenge people intensely, but with very different hats and very different languages. He loved his artists and soldiers equally. When he died, who took his place? It wasn't the ultimate designer artist, it was the soldier. So that's how, contrary to popular myth, when Jobs was successful, he led much more like a gardener than a Moses.
Safi, there's so much we could talk about. There's so much in this book. There's the story of Polaroid, how Polaroid really failed, the Loonshot too far, S-type versus P-type Loonshots. There's so much in the book. It's a fascinating book, a fascinating read for those people who like innovation and like history as well. And you do a great job storytelling many of the failures and successes and why, which is absolutely fascinating reading. If people want to find out more about you and your work, where can they find you, Safi?
Okay, you can go to loonshots.com online or on my Twitter handle, which is just my full name, Safi McCullen.
Author of Loonshots, How to Nurture the Crazy Ideas That Win Wars, Cure Diseases, and Transform Industries. Safi McCullen, thanks for joining us.
Thanks for having me, Aidan. It's been a lot of fun. Loved it.